If you change your mind, take a chance on the first day in line. Honey, I'm still free. Take a chance on me. If you need me, let me know. Gonna be around. If you got no place to go when you're feeling down. Good morning, good afternoon, good evening. We are back and better than ever. Are you feeling down? Then you need to take a chance on calculus, and it's really not even taking a chance because you do the calculus and you feel better. Of course, you already know that. We are talking about tangents and normals again. This is part 2. So let's get right to it. Find the equations of any horizontal tangents to the curve y equals x cubed minus 12x plus 2. Okay, so we already know what the slope of those tangents will be. The slope of those tangents will, or the gradient, if they are horizontal, must be 0. Okay, so we need to find the value of x where the tangents are 0. So that means we need to find the derivative because the derivative gives us the slope of the tangent to the curve. So let's take a look-see. So y prime is going to be equal to 3x squared minus 12. And remember, the derivative gives me the slope of the tangent to the curve. Well, I need the slope of the tangent to the curve to be 0. So when we are now asking at what value of x is the slope 0? So we're going to solve that like it's 1999. We get x squared equal to 4, and I know that you know that x is now equal to plus or minus 2. So what do we do with that? Well, we find, let's think about this. A horizontal line looks like this, yes? And it is of the form y equals k. So now we need the y coordinates on the curvy, not the derivative. The derivative only gives us the slope of the tangent to the curve, and we found out where that slope occurs when the slope is 0. I'm sorry, where it occurs, and it occurs at x equal to plus or minus 2. So we need to find the y coordinates when x equals plus or minus 2. And I will tell you, when we do some substitution, when x equals 2, we replace x in here, we get negative 14 for y. And when we replace negative 2 for x in here, we get y equal to 18. Hence, giving us the equations y equals negative 14 and y equals positive 18. And those are the equations of the tangent lines where the slope, where the tangent lines are horizontal. Don't believe me? Let's take a look right here at our handy dandy TI Nspire CX calculator. There, the gold is the curve in question, y equals x cubed minus 12x plus 2. We have the equation y equals 18 right here. Notice it's tangent when x equals negative 2 at 18. Perfect. And when x equals positive 2, we get negative 14, and we have the graph of y equals negative 14 right there. It is horizontal, and of course it is tangent. And of course this is horizontal, and it is tangent. So we are doing great. So let's go back, do another example. I know you're excited. I am too. Oop, you got a preview there. What's going on? Oh, there it is. Okay, let's go back, see what we did. Okay. Show that the equation of the tangent to y equals the natural log of x, love me some logs, at the point where y equals negative 1 is y equals e to the x minus 2. Okay, so let's see, we're thinking about this. We should know that the graph of the natural log of x looks something like this. And let's see, when x equals the point where y is equal to negative 1 is about here, here, and so this tangent line should look like that. And what they're asking us to do is to show that this tangent line is equal to e multiplied by x, not e to the x, e multiplied by x minus 2. Well, how in the wide, wide world of sports are we going to do that? Well, we need a point, and we know that y equals -1, right? So we need a point on this tangent line. So we need to solve for x on our mother function, our original function here, and find the corresponding x value. So if -1 equals the natural log of x, using our rules of logarithms, remember natural logs have a base of e, so therefore e to the -1 must be equal to x, or 1 over e is equal to x. Okay, so we have a point on the line, on the tangent line. There she is. Okay, and now we need the slope. So we're going to take the derivative of the natural log of x. That's equal to 1 over x. And now we need the slope at the point where x is equal to 1 over e. So I take y prime of 1 over e, and I replace x with 1 over e, and I get 1 over 1 over e, which is simply equal to e. So then my equation is going to look like this. Point slope form, y minus y1 equals m times x minus x1. And remember, our goal is to show that it is equal to that. So this would be y minus a -1, so that's going to be y plus 1, is equal to the slope e times x minus 1 over e. Minus 1 over e. Okay, so let's see what happens here. So y plus 1 equals ex. E times x is ex. E times minus 1 over e, the e's cancel, and this becomes -1. Subtract 1 from both sides, we get y equals ex. I think I've been saying e to the x. I apologize for that. This is e multiplied by x. So ex minus 2 as required. Let's take a look on the calculator just to prove it to ourselves. Seeing is believing. There's a natural log of x. There is e times x minus 2. I had to put the first power there. It doesn't let me just put e yet, I don't think. And there it's tangent at 0.368, -1. And they asked us to show that it was, that's the 0.1, well, we should know, we said that would be the 0.1 over e, and if you don't believe me, I'll go to the scratch pad, and you will see that 1 over e is equal to 0.368 rounded to 3 significant figures. Okay. I'm going to stop there. That is the end of part 2. We will be back soon. See ya!